Okay, so let's get this rolling here. If you have the document that I sent you earlier, you can follow along with that. Otherwise, I'll just go through it step by step, just like I normally do. That way, when you access the video for your homework, everything's in sequential order according to the document that you were sent. So the first thing we're going to talk about is the naming of angles. So I tried to leave out anything that absolutely wasn't necessary. So I'm just going to cover the very basics of this part. So the naming of angles, let's do this. Gotta. All right, here we go. All right, still not good enough. Okay. Good. All right, naming of angles. So first thing we're going to do is we're going to identify this triangle, or this angle. So naming of angles are usually done by means of 3 letters, by a number, or just by a single letter. So for instance, we could have the angles written this way. We could have them written this way. And we could have them written this way. So essentially, this is the 3-letter identification. So this actually would be identified as angle ABC. This one is identified as angle A. And of course, this one is identified as angle 1. So any of these are fine. The only thing that I want you guys to be aware of is that when you're using the 3-letter naming of an angle, you see B here. B is where the vertex is. So when you're using the 3-letter naming for an angle, the middle letter must be the middle of the angle, otherwise known as the vertex. Okay, so make sure that that doesn't change. Don't call this angle ACB if B is here. Okay, so whatever letter is at the vertex, that's the center letter. And that's the reason we bring that up is because this is an industry standard, and we don't want you making those types of mistakes when you're in industry. Okay. The other things we want to talk about is the names of angles. So it may be a long time since you've done this, but the first angle we're going to talk about is an acute angle. Okay, an acute angle is any angle that is less than 90 degrees. Okay, if you can somehow commit these to memory so that when you see an angle, you know what kind of angle that is, that's going to help you when we go through the principles of geometry and quickly being able to identify angles that are the same based on where their location is according to a transversal. So if you can remember these definitions, that would be very helpful. Of course, a right angle is 90 degrees. An obtuse angle is an angle greater than 90 but less than 180. Okay, so if you can remember that, greater than 90 but less than 180. Then I think we've mentioned this one before. A straight angle is 180 degrees. Very important in geometry. A lot of the questions that you come across that are hard to solve are going to be solvable if you can remember that a line a straight line is an angle. So just a little bit of foreshadowing for you here. And then of course we've got a reflex angle. A reflex angle is greater than 180 degrees. Okay, so these are the angles that we're going to be talking about, especially when it comes to the next, I think it's the next 3 lessons in math. Okay. All right, let's go. Just so I don't have to do this again. All right, let's talk about adjacent angles. Okay, so what is an adjacent angle? 2 angles are adjacent if they have a common side and a common vertex. So let me give you a demonstration here. So if we have this figure here, yeah, let's just choose undo for that. We got to make this straight for it to make sense. All right. So we have 2 angles here. We'll call this one angle 1, and we'll call this angle angle 2. Okay. I'm not going to waste a lot of time on making sure my art is perfect here. You'll get the idea. All right, so we're gonna label the points. Remember we talked about points last week. All right, so the definition here, an adjacent angle. 2 angles are adjacent if they have a common side and a common vertex. Let's analyze this drawing here. We got angle 1, we have angle 2. Are they adjacent? Do they meet the criteria? Well, number 1, they share a common side, right? So this right here is a common side because this angle uses it and this angle uses it. The other factor is that they have a common vertex. So where this angle meets this shared line and where this angle meets this shared line is right here. So they in fact share a common vertex. So you could say that angle ABC and angle CBD are adjacent angles. Okay? They have to have a shared side and a common vertex. What would be an example of 2 angles that are not adjacent? So if we had this scenario here, okay, and we have angle 1, I won't draw the arrows, we'll call this angle 1 here, and we'll call this angle 2 here. Okay, angle 2 we can draw the arrows for on the inside, and angle 1 will utilize this arrow and this arrow. So we've got our 2 arrows. Do they share a common side? Well, absolutely they do, right here. But what they don't share is a common vertex. Okay, so these 2 angles, although they share this side and they are relative in some sense, they are not adjacent. Okay, so just a good example of adjacent angles and what does not qualify as an adjacent angle. What about a transversal? So a transversal is a line that intersects 2 or more lines. So if I were to draw this line and this line, okay, we'll say they're parallel, and then I draw this line here. This third line that we drew, this is what a transversal is. Okay, so a transversal is a line that intersects, so you can see it intersects here and it intersects here. It's a line that intersects 2 or more lines. Very important in geometry, okay? So if you can remember this, or make sure to refer back to this video, it will be very helpful to you. Okay. Alternate interior angles. Alternate interior angles are pairs of interior angles on opposite sides of a transversal. The angles have different vertices. So let's do a little demonstration here. So if we've got, there's point A and point B, and then we have point C and point D, and then we have this transversal, E and F, okay? So if we're looking for, sorry, I gotta get my glasses or light. Alternate interior angles. They're on opposite sides of the transversal. So this is your transversal. Where are we here? This is your transversal down the middle. Okay. Alternate interior angles are on opposite sides of this transversal. Okay, but which ones qualify as the interior angles? So if you look at, maybe what I should do is draw these. Just going to draw in these angles real quick. It's not going to be perfectly centered, I apologize. Okay. All right, so these are our angles that we're talking about. Okay. And we'll label them too so we can refer to them. So we'll call this angle 1, angle 2, angle 3, okay. So if you look at angles, let's say 3 and angle 5. Notice the definition again: alternate interior angles, pairs of interior angles on opposite sides of the transversal, and they have different vertices. So this angle right here, angle 3, is on the right side of the transversal. Angle 5 is on the left side of the transversal, and they do not share the same vertices. So it could not be angle 4, because angle 4 and 3 share the same vertex angle right here, right? So it has to be opposite interior, but they can't share the same vertex. So 3 and 5 are alternate interior. So therefore 4 and 6 are also alternate interior angles, okay? Corresponding angles. Now I don't know if I put that on your list, but we need, yeah, I did. Okay, so corresponding angles are pairs of angles, one interior and one exterior, with both angles on the same side of the transversal. So if you look at, let me just get rid of these here. Okay, so if you look at angle 1 here and angle 5, does that fit our definition? Pairs of angles, one is an interior, one is an exterior, and both are on the same side of the transversal. So we just have to make sure we understand what an interior and exterior angle is. So angle 4, 3, 5, and 6 are all interior. So think of it like they're sandwiched between line AB and line CD. They're on the inside, right? Angle 1 and 2 and 8 and 7 are on the outside, so they're exterior angles, right? So it's based on their location in this figure, or in whatever figure we're talking about. So these corresponding angles, angle 1 and angle 5, they're on the same side of the transversal, but angle 1 is an exterior and angle 5 is an interior. That would mean then that angle 2 and angle 6 are corresponding angles. That would mean that angle 3 and angle 7 are corresponding, and angle 8 and angle 4 are corresponding. Okay. I know some of the definitions can be a little bit confusing, but that document that I sent you, if you can keep that, and maybe even just when you go back to this video, just make little sketches next to those definitions, it'll be very helpful, especially when it comes to your homework, and then when we end up having our test on geometry. Okay, so the main thing that we are going to be covering today, and if you are a good note taker, I would try and jot down some things here. This week's lesson and the lesson that we take in January are going to be based on the principles of geometry. So the principles of geometry, basically, think of them like the go-to, right? They're like the rules. If you want to solve something, you have to understand, or sorry, if you want to solve something in geometry, you have to understand what principles that you have to abide by, or which principles apply. So to give you an example of that, we're going to cover 5 principles today, and the first principle is, they just call them principle 1, principle 2, principle 3, etc. The first one that we're going to talk about, principle 1, states this. It says that if 2 lines intersect, the opposite and vertical angles are equal. Okay, so let's demonstrate it. So if 2 lines intersect, there's 1 line and 2 lines. The rule is, in principle number 1, that the opposite or vertical angles are equal. So this angle here, right? This angle here and this angle here. Okay, so when I make an, for instance, the x here is referring to this angle right here. Okay, and I'm just demonstrating that if I put an x here and an x here, they're the same value, right? So this angle and this angle are the same. Therefore, these vertical angles are the same. So principle 1 again says if 2 lines intersect, the opposite or vertical angles are equal. Technically, it's the opposite and the vertical angles are equal. Okay, so this helps us when, for instance, let's say we're given, I give you this angle right here. I tell you that this angle right here is, let's say it's 30 degrees. And then I want to know, let's call this angle 2, angle 3, and angle 4. And 30 degrees is angle 1. Okay. So if angle 1 equals 30 degrees, what is angle 4? Okay, so this is where the principles of geometry and understanding the definitions of our lines are helpful, or the definitions in geometry are helpful. If we know that this is 30 degrees, we know that this is also 30 degrees, because principle 1 states that these two have to be the same. Okay, so we now know, in fact, that this is 30 and this is 30. That takes 60 away. But do we know angle 2? We want angle 4. What is angle 2? Well, some basic things. We know that a circle equals 360 degrees. In fact, remember we talked last week, if you took a radius array and this is your pivot point right here, and this is your ray right here, and we take that ray and we move it all the way back into this position, we get 360 degrees. If we stop that ray at any point, there's an angle that develops. So if, let's say, the ray started here and we move it into this position, we know that we've moved it 30 degrees. So if we continue to move that ray all the way around, it'll be 360. So we know that these 4 angles, they have to equal 360 degrees. So 360 minus 30, we know that this is 30 because these are equal. So 360 minus 60 equals 300 degrees. So we know that angle 4 and angle 2 total is 300 degrees. We know based on principle 1 that this angle and this angle are the same. So really we'll just take this 300 degrees and we'll divide it by 2. Therefore we know that angle 4 equals 150 degrees. And if you're ever unsure, I know you've when in high school and you were doing math, I know that you were told to prove your work by working backwards, right? So if you were to add up 150, right? 150 plus 150 plus 30 plus 30, you should get 360 degrees. And if you do, then you did your math right. Okay, so again, I listed the principles for you. Make sure you keep that sheet so that you can refer to it when it's time for you to do your homework. Okay, principle 2. All right, let's go back to this example. All right, principle 2 states, if 2 parallel lines are intersected by a transversal, the alternate interior angles are equal. So we remember what the alternate interior angles are, right? Alternate interior angles are going to be angles that have different vertices, but they're also on opposite sides of the transversal. So we could say that B, I'll have to put my angles in here, sorry. We'll call this angle 3, angle 4, angle 5, and angle 6. Okay, principle 2 says if 2 parallel lines are intersected by a transversal, the alternate interior angles are equal. So angle 4 and angle 6, they are the same. So I want you to look at the screen here and really try and get this into your brain. This we just finished talking about principle 1, right? In principle 1, we'll just draw a little demo of it right here. All right, we'll just draw it right here, and then I'm going to take my eraser. Yeah, I'm just going to erase this. So this shape right here, I drew it smaller here, but really principle 1 could be demonstrated up here at the top, right? This angle here are the same. This one and this one are the same. When 2 lines cross, right? We understand that principle. this transversal is running and intersecting two lines. Those lines are parallel to one another. That's part of principle 2, right? Is that those lines have to be parallel. So if this line and this line are parallel to one another, I could technically take this shape, pick it up, drop it over top of this shape, and you wouldn't see the two, you just see one. They're identical, right? Because this line and this line are parallel, they will drop right on top of one another. And because this is a shared line, it's in the same place, right? So if this angle and this angle are the same, they're also the same as this angle and this angle. And these two angles are the same. So if we called this angle 1, 3, 5, and 7, 1, 3, 5, and 7 are all the same angle, right? As is 2, 4, 6, and 8. Okay, so this takes us back to principle 2. If two parallel lines are intersected by a transversal, the alternate interior angles are equal. Well, is that true? Here's an interior angle. Here's another interior angle. I'm saying that they're true. Does this say that they're true? Well, this is angle 4 according to this, and this is angle 6 according to this. So it is true. Okay, so again, it would be a good idea to redraw or sketch these somewhere, or put them right in that document that I gave you. Okay. Now there's a second part. Some of these principles, they have an A and a B, and basically all it is it's just stating the same thing but in reverse, or referring to the other angles that are affected by this principle. So that B part of principle 2, it says if two lines are intersected by a transversal and a pair of alternate interior angles are equal, the lines are parallel. So in other words, it's just saying it backwards, right? If you want to know if these two lines are parallel, then you would have to be told the value of the alternate interior angles. And if the alternate interior angles are the same, and there is a transversal that goes through two lines, then now you know those two lines are parallel. Okay, so it's just doing it backwards. And I know it sounds like a lot of back and forth, but these things are important because this helps you with your problem solving. When you know a principle, but it doesn't look like you have enough information, go back to the principle and say, well, what principle applies here? How can I solve this based on the principles? Now, not to scare you, but there's a lot of principles. I think we now in your first level, you guys only, I think you only take, don't quote me on it, but I think we only go up to like principle 14. But I think there's upwards of 30 principles that we eventually talk about when it comes to the advanced technical math. Okay, let's go on to principle number 3. Okay. Come on. Something's working hard on my computer. I'm not sure what. Okay, principle number 3. It states if two parallel lines are intersected by a transversal, the corresponding angles are equal. Let's just go back to this for a second instead of redrawing it. Okay, so I'm going to just get rid of these. So principle 3 says if two parallel lines, so AB, CD, are intersected by a transversal, EF, the corresponding angles are equal. So remember what a corresponding angle was? Corresponding angle are pairs of angles, one's interior, one's exterior. So let's call this is angle 1, 2, 3, 4. All right. So angle 1 and angle 5 are corresponding angles, right? One's an exterior, one's an interior, and they're on the same side of the transversal. So they're both on the left side of the transversal. So principle 3 states that if there are two parallel lines intersected by a transversal, the corresponding angles are equal. Angle 1 and angle 5 are equal to one another, right? Angle 3 and angle 7 are equal to one another. Angle 8 and angle 4 are equal to one another. And angle 6 and angle 2 are equal to one another. Does this look true on this side? Right? So X, all the X's mean they're the same angle. All the O's mean they're the same angle. So I'm saying angle 1 and angle 5 are the same. Is that true? Angle 1, angle 5, they are in fact the same. Right? Angle 3 and angle 7, angle 3 and angle 7, they are the same. Okay, so that's your principle 3. Again, that's in your document that I sent you. All right. And we can probably use this for... All right, we'll use this same one. I don't have to draw it again. Where are we? Principle 4. Can I use this one even? Yeah, I'll just redraw it. Okay, forget it. I'll just redraw it. Okay, this one states two angles are either equal or supplementary if their corresponding sides are parallel. So here's what this means. So let's take this line and draw, and then we're going to draw this one directly across from it, and we're going to draw this line here. Okay, and this isn't to scale obviously, so draw this the best that I can. We're going to say that this is angle 1 and this is angle 2 and this is angle 3. All right, and let's label these as well. Okay, so we label every point so we know what we're talking about. All right, two angles are either equal or supplementary if their corresponding sides are parallel. So here's your givens. AB is parallel to FG. So you have to know the information, right? So I'm going to tell you what what is true so that we can solve this. BC is parallel to DE. All right. Line AB, it's parallel to FG. So basically remember that we could therefore take FG, pick it up, drop it over top AB, and they would line up perfectly, right? They're parallel to one another. They run exactly the same direction. We're also saying that line BC is parallel to DE, okay? So based on that information, the conclusion is, okay, so the conclusion is angle 1 here is the same or equals angle 3 . Okay, make sure, yeah, conclusion angle 1. Geez, I can barely read. Okay, good. All right, and then angle 1 and angle 2 are supplementary. So why this is important is often in geometry, the angles that we're talking about are not part of the same figure. And in machining, a lot of times when we're trying to locate features on a part so that we can program to manufacture these parts, features will be the same but located in different places, right? So we may have two bolt patterns that are identical, but they're not in the same place, right? So we can take the geometry from one, as long as we know what principles we're observing, we can solve the information on the other bolt circle or other features. So this is a good example of that. This angle here could be somewhere on the print and is required information for manufacturing. And then this layout, you know, maybe it's whole locations or whatever it may be, could be located somewhere else on the print. But if we have absolute information, if we know what principles apply, if we know that AB on the print is parallel to FG, and perhaps they share the same baseline, B, C, D, E, they could essentially be one line, right? They don't have to be, as we demonstrated down here, right? They could be two separate lines. And then we have our second angle here, right? And our other angle here. So they don't have to be joined, they just have to be parallel. Then we could solve this information. And why this is important, okay, supplementary angle is basically this. We know that a line is 180 degrees, right? So if I know, let's say I know that angle 1 equals 30 degrees, and I'm trying to solve angle 2. I want to know what is this angle here, and this here is angle 3, right? All I've told you is angle 1 is 30 degrees. That's this one here, 30 degrees. If AB is parallel to FG and BC is parallel to DE, then angle 1, right? Angle 1 equals angle 3. They are the same. Angle 3 is also 30 degrees. They have to be. So can I solve angle 2? Absolutely. I know that a line DE is 180 degrees. So if I subtract the movement of this ray, which is 30 degrees, from 180, I know that angle 2 is 150 degrees. Okay, so I can solve this based on an angle somewhere else, as long as I know what principles apply. You know, the unfortunate thing is that a lot of this is covered in high school, but I know that the way things have to move, if you don't pick up on this right away, the next few lessons in math are just gone. If it's anything like when I went to school, and I remember specifically trying to catch up with geometry, and it was game over. So what I would like you guys to do, one of the reasons besides the holidays, that I don't want to give out homework for this, is I really want you to try and comprehend the principles that we're talking about, okay? The last principle that we're going to talk about, which is going to bring us to the end of our session here. I'm not exactly sure why this, there we go. This one's a little tougher. So we'll see if we can, I'm going to try and draw it up here, and then I'm going to do a second example. Now, I'm telling you that this is a straight line, all right, no matter how it looks. And we're just I'm gonna make this just a little bit clearer. All right, they're all straight lines, all right, trust me. Okay, so principle 5 says that two angles are either equal or supplementary if their corresponding sides are perpendicular. So we, just a moment ago, dealt with this and this, right? Parallel to each other, parallel to each other, okay? What I've done now is I've taken this and I have rotated it 90 degrees, okay? You see it? This is this, rotated 90 degrees. All right, so here's the rule for this principle. Two angles are either equal or supplementary if their corresponding sides are perpendicular. Well, let's identify the parts of these triangles so that we can get this. So this is point A, B, C. I'm going to take this down just a hair. Okay, this is D, point E, F, why in the world did they use, silly. All right, and we're going to call this H like they did. I'd have called it G, but whatever. Okay, you know what, that's dumb. We're going to call it G. Somebody made an error. I don't need to make it too. All right, point G. All right, so I want to know the value of some angles here. So let's go, this is angle 1 in this is angle 1 in here. Angle 1 here. And angle, this is angle 2. And this is angle 3. So it looks familiar, doesn't it? This was our angle 1, angle 2, angle 3, same angles. Okay. And the rule is they have to be perpendicular to one another. So therefore, if we were to join these lines, we would be able to prove that this corner here is in fact 90 degrees. And we would be able to prove by finishing that line that this is 90 degrees here, right? Without these 90-degree symbols, we wouldn't know if this was at right angles. So all I've done is I've drawn these in so that it proves that this here, I've rotated 90 degrees. Okay, rotate 90 degrees. I prove it by putting my 90-degree marks there in the corners. This is what makes this principle true. Two angles are either equal or supplementary if their corresponding sides are perpendicular. So angle 1, friends, is still the same as angle 2. It only works, okay, principle 4 and 5, okay, they only work whether when the lines are parallel to one another or perpendicular to one another. That's it. Any other angle, these principles don't apply. So if you don't see, or if you can't identify two angles being perpendicular to one another, or if they're like, if it's not called out, or if it's not called out that they're parallel, we don't assume. And that if you can take something away from today's lesson that is critical for geometry, you cannot ever assume. Just because something looks like it's one way or looks like it's the answer doesn't mean it is. Everything is provable, and it's all provable based on principles.